Hello learners and welcome to your natural sciences lesson. So today we're going to be doing practice questions that are based on the reactions between an acid and a metal hydroxide. So let's start. The first question that we are given, it says we need to give the general formula of the following reactions as a word equation. So we need to give the general formula as a word equation for the reaction between an acid and a metal hydroxide. So what is going to be formed, what is going to be the product when an acid reacts with a metal hydroxide? So acid plus metal hydroxide. We know that the acid always has an H in front of the molecular formula. The metal hydroxide has an OH within the molecular formula. Then the acid will give off its hydrogen, and then the metal hydroxide will donate its OH, the hydroxide. Now, when those two donated substances combine and react together, they are going to form water. Then the remainder is going to combine and react together to form the salt. So the products of this reaction is going to be salt plus water. Remember that the pH of this salt depends on the pH of the acid and the pH of the hydroxide. So whichever one that is higher or whichever one that is stronger than the other, should the acid be stronger than the base, then the salt is going to be more acidic. Should the base be stronger than the acid in terms of its pH or in terms of its strength, then the salt is going to be more basic. Right? However, should they have the same amount of strength, then the salt is going to be neutral. Then the next question says, the reaction between an acid and a metal oxide. So what is going to happen when we react an acid and a metal oxide? So we are going to have an acid plus a metal oxide. So what is going to happen? We know again that the acid has a hydrogen in front of the molecule, in front of the molecular formula. So that hydrogen can be donated, and then in this case, our metal oxide doesn't have the hydroxide, it doesn't have the OH, it only has the O. So it is going to donate that oxygen. Then the acid will donate the hydrogen, then the metal oxide to donate the oxygen. Now, when those two substances combine together, they will still form water. However, in this particular one, we need then to balance the reaction. So, however, the product will always be salt plus water. And then we need to balance the reaction so that we know that the number of atoms on the left-hand side will be equal to the number of atoms on the right-hand side. So depending on what we have on the left-hand side, the number of those atoms, they must still be equal to the number of atoms on the right-hand side. If we had HCl or H something on the left-hand side, the number of hydrogens on the left, if they are 3, they should still be 3 on the right-hand side. If we have a metal oxide, let's say magnesium, for instance, on the left-hand side, if it's 1, it should still be 1 on the right-hand side. Should it happen that we now have 2 magnesiums on the right-hand side, then we need to balance so that on the left-hand side we have 2, also on the right-hand side we also have 2 magnesium. So question 3, again we need to write the reaction between an acid and a metal carbonate. So again, the word equation for this reaction. So we know that we have our acid plus our metal carbonate we need to know what the product is going to be when these two substances react together. So initially we said when an acid reacts with a metal hydroxide, the product is salt and water. Same when an acid reacts with a metal oxide, the product is salt and water. However, when an acid reacts with a metal carbonate, there's going to be 3 products that are going to be formed. Yes, the salt is going to be there, the water is going to be there, but there's going to be a third product, which is a gas. Now, which gas is it going to be? We have the salt, plus we also have the water, and then plus the gas. We need to know what gas this is going to be. So for us to be able to do that, we need to use a practical example of, let's use the HCl as our acid, hydrochloric acid, plus the metal carbonate, that is now going to be calcium carbonate. So all the metal carbonates or all the carbonates, they have the CO3. As much as we said that the hydroxide have the OH, the carbonates have the CO3. So hydroxides have the OH and then the carbonates have the CO3. Now, when these two substances react together, the salt, water, and gas are going to be formed. Now, our salt is going to be the calcium chloride, because when the H now, when the acid donates the H, there's going to be that which is going to be left over, which is the chlorine. And then on this carbonate, the carbonate is going to now break from the calcium, then the calcium will bond, chemically bond with the chlorine to form the calcium chloride. Now, because these are in different groups, this is in group 7, whereas this is in group 17, whereas this is in group 2. So we are going to have now to have a Cl2 to show that for every one atom, or for every one atom of calcium, we need 2 atoms of chlorine to have our salt being the calcium chloride. Then obviously our water is H2O. Then the remainder, as you can see, what is it going to be? You guessed it, because there's a C and then there's a O that we're seeing in this reaction. So the gas must be CO2, which is our carbon dioxide. So on this reaction, you need to note that there needs to be balance. There needs to be a balance in terms of the number of atoms on the left-hand side and the right-hand side. We can see that this reaction is not balanced. How do we see? Starting from there. Cl. On the right-hand side, there's 2 of them. We have 2 chlorines. However, on the left-hand side, we have 1 chlorine. So that reaction still needs to be balanced because it is not balanced. So what we need to know about the reaction between an acid and a metal carbonate is that there's going to be 3 products that are going to be formed. Salt, yes. Water, yes. And then the gas. That gas is going to be carbon dioxide. Now, moving on. Again, we need to write a weight equation and a balanced equation. So now we need to balance the equation for each of the following reactions. So the hydrochloric acid, as we know, HCl, reacting with calcium hydroxide. So we need to write the weight equation and also a balanced chemical equation. We know HCl is hydrochloric acid. Reacting with calcium. We know that this reaction is going to form salt and water, but then what salt and what water? This is our HCl plus calcium hydroxide, so it's CaOH, and then CaOH reacting to form. We know that the H is going to be there, and then there's going to be the OH to form our water. And then the product is going to be our salt, which is calcium chloride, plus H2O. Then we need to balance the chemical equation. So obviously our salt in terms of the weight equation, it's going to be calcium chloride. And water as our products of that reaction. So now we need to balance this reaction because we are seeing that on the left-hand side, we have how many hydrogens? This 2 goes for everything inside the bracket. So that means we have 2 oxygens and we also have 2 hydrogens. So 2 hydrogens plus 1 hydrogen, we have 3 hydrogens on the left-hand side. However, on the right-hand side, we only have the 2. So if I now, okay, now let's move on, going to the other ones. We have 1 chlorine, so we have 3 on the left-hand side, 3 hydrogens on the left-hand side, and then we have 2 hydrogens on the right-hand side. With regards to the chlorine, we have 1 Cl on the left-hand side, and then we have 2 Cl on the right-hand side. Then we also need to look at the oxygen that we find on the left-hand side and the right-hand side. We have 2, because of that 2, we have 2 oxygen, and then on the right-hand side, we only have 1 oxygen. Then lastly, the calcium, we can just squeeze it in there. We have 1 calcium. And then on the right-hand side, we also have 1 calcium. So the calcium isn't giving us a problem. The other ones are not balanced. So let's start. So you're going to start by balancing out the hydrogen. So if we put a 2 on the right-hand side of this hydrogen, so we're noticing that we have 2 times 2, so we have 4 hydrogens now on the right-hand side, and then the hydrogens on the left-hand side, they are 2. So if we put another 2 there, we notice that on the right-hand side, on the left-hand side, we have 2 hydrogens. And remember, we also have the other 2 hydrogens there. So 2 plus 2 is 4. So the hydrogens are going to be 4 on either side. Now, that 2 now, it is going to affect the oxygen. We now have 2 oxygen on the right-hand side, and we still have 2 oxygen on the left-hand side because of that 2. So the oxygen is going to balance on the right-hand side. And then now the coefficient that you've put there in front of the acid will also affect the chlorine. So that means you're only going to have also 2 chlorine atoms on the left-hand side, and as you can see, 2 chlorine atoms on the right-hand side. So after having done that, you notice that everything else now balances. We have the same number of atoms on the left-hand side as also the same number of atoms on the right-hand side. So left and right are equal in terms of the number of atoms. Now, the next question also is asking us to write the word equation and balance the chemical formula. Hydrochloric acid and lithium oxide, lithium hydroxide. So hydrochloric and lithium oxide, lithium hydroxide. So the product, so let's start by writing out the chemical formula. So we have HCl plus lithium oxide, it's lithium hydroxide, it's LiOH. The product, we know H is going to be donated, the OH is going to be donated, then the product is going to be, or the remainder is going to be lithium and the chlorine. So it's lithium chloride. And then this is going to be giving us our water as the product, H2O. So the name of the salt is going to be, I'm just going to write it down at the bottom here. So it's going to be lithium chloride plus the water. Plus the water. So having done that, we now need to now balance the equation and see if the number of atoms are equal on the left-hand side and also on the right-hand side. Start counting. Hydrogens, 1, 1. So there's 2 hydrogens on the left-hand side. On the right-hand side, that 2 goes for only those hydrogens, so there's 2. Hydrogen is balanced. Chlorine, we have 1 chlorine on the left-hand side and also 1 chlorine on the right-hand side. Chlorine is balanced. Now, lithium, 1 lithium atom on the left-hand side, also 1 lithium atom on the right-hand side. Lithium is balanced. Oxygen, 1 oxygen atom on the left-hand side and also 1 oxygen atom on the right-hand side. So therefore, everything in this equation balances. So therefore, this equation is regarded as balanced. So now, next question. We are supposed to, for the solutions of the following substances, we are supposed to give the name of one example, say if whether the solution will be acidic or basic, and then also say if it has a low or a high pH. So, metal oxide and metal hydroxides. So we need to give the name of one example, a metal oxide. So a metal reacting with oxygen, we can think of magnesium oxide, MgO. And then also, is that going to be an acidic or a basic substance or solution? So all the metal oxides, they are acidic. So that means their pH is going to be low. Whereas the metal hydroxide, they are bases, which means their pH is going to be high. That means it's greater than 7, and the metal oxide less than 7. So MgO is our example for the first one, number 1. And then number 2, solution, it is going to be acidic, because all the metal oxides, they are acidic. And then number 3, say if it is a low or a high pH, then obviously if they're acidic, their pH is low, which means it is less than 7. It's less than 7. Then metal hydroxides, number 1, and then we can think of NaOH sodium hydroxide as our metal hydroxide. Number 2, say if the solution will be acidic or basic. All the metal hydroxides, they are basic, so that means their pH is high. So number 3, their pH is high, which means the pH is greater than 7. So here pH is less than 7. So that's what we have for the metal oxides and also for the metal hydroxides. So before we go on to the next part of our questions, we're just going to go for a short break and I will see you just after this.